The first two questions on the review test you on the asymptotes. We have horizontal asymptotes and vertical asymptotes. Number one is asking for vertical, which is the up and down. And so to get the equation of that line, look at where it actually crosses. It crosses the x-axis at -2, letter C. For the horizontal asymptote, it crosses the y-axis, which is going to be y equals and -1. So the answer is letter D. So be careful to look at where it actually crosses. A lot of students think horizontal means x equals and vertical means y equals. That is not the case. Number 3 asks for where is the hole. Here's the hole, and the x value of the hole is at -2, letter A. The next 4 questions on the review is testing you on how to find the horizontal asymptote by looking at the equation. The only thing that you need to look at is the biggest exponent. So for number 4, on the top, the biggest exponent we have is a 1, and on the bottom is also a 1. So because the top and bottom have the same biggest exponent, the horizontal asymptote will simply be the coefficients of this, so 5/7, letter A. And this is also similar to if we jump over to number 6. You see how number 6, the biggest exponent on the top is 2, and on the bottom is also 2, so because they're equal, the horizontal asymptote will simply be 3/10, letter A. Now look at number 5. For number 5, the biggest exponent on top is 2, but the biggest exponent on the bottom is 1. So when the top is bigger than the bottom, imagine you have a big number divided by a tiny number. There is no limit. It will be a humongous number, so there's no horizontal asymptote. And then for number 7, the biggest exponent on the top is 1, the biggest exponent on the bottom is a 2. So now the bottom is bigger, so we have a tiny number divided by a big number, which is y equal to 0. So for the test, make sure you understand the 3 cases. What happens when the exponents are the same on the top and bottom? What happens when the top is bigger? And what happens when the bottom is bigger? Number 8 and number 9 are both testing you about excluded values. There are 2 types of excluded values, and they both happen when the bottom, whether your denominator is equal to 0. So you want to focus on the bottom. So let's look at number 8. So I'm going to put parentheses around this, x minus 7, so that's one single factor. So we want the vertical asymptote. So you see the x minus 7, they cross out. So that's actually the hole. So the vertical asymptote is what does not cross out, which is here the x plus 2 factor. So we're going to set that equal to 0 because we don't want the bottom to be 0. So x plus 2 is equal to 0, which means that x is equal to -2, letter D. Make sure you actually write this out and set it equal to 0, then solve it. Because if you don't, you will accidentally pick letter C, which is the bait answer choice. And I will put that bait on the test for students who don't want to write it out. For number 9, what you need to do first is you need to factor your denominator. So to factor this, so what times what is 35? We can do 5 times 7. So 7 needs to be negative because it's a bigger number and we're trying to get -12, and 5 also needs to be negative. So -7 minus 5 is -12. So that means the bottom can now be factored as x minus 5 and x minus 7. Which you see the x minus 5 on top and bottom, they cancel out. But for the whole, you want the factor that cancels out. That's the difference between wholes and vertical asymptotes. Vertical asymptotes, you want the factor that is not cancelled out. And for wholes, you want the factor that is cancelled out. So going to take that factor, x minus 5, set it equal to 0, solve it, x is equal to positive 5, which will be letter D. And so you see the bait answer will be letter C, x equals to negative 5. Number 10, we are just multiplying two rational expressions together. So when multiplying and dividing, you don't need to worry about getting the same denominator. So I'm going to put parentheses around the n minus 5 and the n minus 5 to show that the n minus 5 is just one factor. Now I will look for pairs top and bottom. So here we have an n minus 5 and here we have an n minus 5, so that cancels out. Here we have an n minus 5 and another n minus 5. So what are we left over with? We have n plus 5 on the top, n minus 7 on the bottom. And that's your answer. Number 11, we are dividing the polynomials, the rationals. So when dividing, what you want to do is take the second fraction and flip it upside down. Now we can just multiply. We can just treat this like multiplying. Now I'm going to cross this out. So don't look at the original anymore. So I'm going to put parentheses around this n plus 6 and see what we can cancel out. N plus 6 on the top, n plus 6 on the bottom, n minus 5 on the top, n minus 5 on the bottom, n minus 4 on the top, and n minus 4 on the bottom. So all we have left over is we have a 6 on the bottom, and that's it. Nothing's on the top anymore. So you can leave a 1. 1 over 6 is your final answer. Number 12, because of the division, we're going to rewrite this as a multiplication but flipped upside down. So n squared plus 5n minus 6, and on the bottom we have n minus 1. So I'm going to scribble this out so we don't look at it anymore. I am going to add parentheses here and here to show that they are just one single factor. And now we need to factor this top part over here. So okay, let me bring this down so we can have room to factor. So when factoring this, what we get is going to be n plus 6 and n minus 1. So I'm going to cross this out. Now let's see which factors we can cancel out, top and bottom. So on the top we have an n minus 1, on the bottom we have an n minus 1, and that's it. So what's left over, we have on the top we have a 1 multiplied with n plus 6. But we don't need to worry about that 1, we can just write n plus 6. And here's the reason. Because when you multiply by 1, nothing changes. 1 times 5 is 5, for example. 1 times 8 is 8, for example. So 1 times n plus 6 is just going to be simply n plus 6. And the bottom, we have simply n minus 4. That's your final answer. For number 13, because we have a division here, let's turn this into a multiplication, flipping it upside down. 8x plus 16. Scribble this out so we don't look at it anymore. Okay, we need to factor this part. So this will be a x minus 6, x plus 2. Now this is gone. We can also factor out this part, because you see how both the 8 and the 16 can divide by 8. So we can factor out 8. So 8 times what is 8x? 8 times x is 8x. And 8 times what is 16? 8 times 2, 16. So scribble that out. Now let's find twins, so we can cross out 4 with the 4. X plus 2 on the top, x plus 2 on the bottom. And what we are left over with is x minus 6 on the top and 8 on the bottom. Number 14 is just testing you on, do you know what is a factor? The definition of a factor are things that are multiplied together. So you see how here we have a minus. So we know that 3n minus 11, they're not separate factors. They have to be one factor. So this is one factor, so I'm going to put parentheses around this. So let's count. There are 5 factors because 5 is a factor, n is a factor, n plus 7 is a factor, n minus 3 is a factor, and 3n minus 11 is a factor, so we have 5. So what's really happening here on the bottom is you have 5 times n plus 7 times n minus 3 times 3n minus 11. So there are 5 things multiplied together, therefore 5 factors. The reason I want to show 15 and 16 side by side is both 15 and 16 have the common denominator, which is important when you're adding or subtracting. So you see on number 15 is subtracting and number 16 is adding. Here's the only difference. When subtracting, change the sign. So you see this positive x, make that into a negative x. You see this positive 1, make that into a negative 1. Scribble those out so you don't have to worry about it. Then we combine like terms on the top. We have 3x minus 1x, that's 2x. And then bring down the minus 1. That's all we got. On the bottom, we have x plus 1, x plus 5. And that is the answer for number 15. For number 16, we don't have a negative in front of any fraction, so we don't even need to worry about changing any signs. So let's combine like terms. Let's put the a's together. We have 1a plus 5a, which is 6a. Be careful, it's not a squared, because a squared means a times a, but we're not multiplying these two a's together, we're just adding them. And then we have negative 1 plus 4, which is positive 3. On the bottom, we have 6a squared, a minus 5. So just the common denominator on the bottom. That's your final answer for number 16. For number 17, notice how we have different denominators, and we also have this negative sign. So let's change the sign over here. So that 3 becomes a negative 3. But notice something. This 3 and this 3, they cancel out. So what we really have left over here is a negative 1. So that cancels out, gonna leave a negative 1 here on the top. Now, I'm going to put parentheses around this. So what does the first fraction need? The first fraction still needs a 2x plus 1. So right here, 2x plus 1. And the second fraction still needs the factor x minus 2. So now we just need to distribute. 5 times 2x is 10x. 5 times 1 is 5. Negative 1 times x is negative 1x, and negative 1 times negative 2 is positive 2. Now combining like terms, 10x minus 1x is 9x, 5 plus 2 is 7. On the bottom, we just have the two factors, x minus 2 and 2x plus 1. So basically, to get the common denominator, you just need to multiply by whichever factors the fraction is missing. So here for number 18, we have this negative sign, so let's change that 7 to a negative 7. And we need to factor this part. So what we get is m plus 8 and m minus 6. So I'm going to put parentheses around this to show that this is one single factor. So now look at all the factors we have. We have an m plus 8 and m minus 6. To get the same denominator, the second fraction simply needs the m minus 6. It already has the m plus 8, but it does not have the m minus 6. So I'm going to multiply this by m minus 6. Now, bring down the 6. Negative 7 times m is negative 7m. Negative 7 times negative 6 is positive 42. Combining like terms, we have, let's put the term with the variable first, and then we have the 6 plus 42, which is 48. And the denominator is going to be the two factors that we have, m plus 8 and minus 6. And that's your final answer.